In ad hoc human-robot collaboration, humans and robots work on a task without planning which actions they will take prior to execution. Instead, task allocation occurs in real time. When completing collaborative tasks, it may be hard for the human-robot team to coordinate their actions. For instance, the human and robot may unintentionally attempt to pick up the same objects. They may even attempt to place objects at the same location. The lack of coordination in such tasks could lead to inefficiencies or issues of safety. Inspired by HCI research on territoriality and proxemics, we propose a design space of techniques for real-time task allocation. These techniques can be explicit or require users to take deliberate action to allocate objects, or they can be implicit and require the robot to make inferences about task allocation. We propose 4 explicit techniques: a baseline technique called voice, and 3 other techniques called menu, subtle, and fixed. With the voice technique, the user can request the robot to pick up an object by requesting the number that appears on top of it.
6, 5, 1.
Through this technique, the user can touch an object or point at it to bring up a menu. They can then assign the object to the robot, the user, or even cancel an allocation. Through the subtle technique, the user can assign objects to the robot by pushing it in the robot's direction. Likewise, pushing in the user's direction assigns the object to the user. With this technique, the table is divided into 3 territories: red belonging to the user, green belonging to the robot, and white belonging to the group. The user can manipulate objects between these territories to allocate objects to the robot, themselves, or cancel an allocation. We also propose 4 implicit techniques: a baseline technique called proactive, and 3 other techniques including distance, gaze, and proximity. As part of this technique, the robot picks up objects closest to where its gripper or hand is currently positioned. Through this technique, the robot selects objects based on their distance relative to its fixed base. It always picks up the object closest in distance, which the user can manipulate by moving the object towards or away from it. In this technique, the user's gaze determines where the user's territory in red and the robot's territory in green are located. The robot selects objects in its territory or in the group's territory, but avoids objects in the user's territory. With this technique, the user's and robot's activity in a region determine territories. Picking up an object from a region causes that region to be considered the user's or the robot's territory, respectively, depending on who picked up the object. When objects are to be assigned, the robot selects those nearer its territory or the group's territory, but avoids objects in the user's territory. To evaluate the techniques, we conducted an experiment where users completed a block stacking task with different configurations. Users were tasked with stacking yellow blocks, while the robot had to stack black blocks. However, neither were provided a rigid sequence in which the blocks on the table had to be placed. This had to be determined during task execution. In the first task, participants completed a coupled task where each alternate block belonged to the user or the robot. Additionally, blocks belonging to the robot and the user on the table were randomly placed. In the next task, which was also coupled, objects belonging to the user and the robot were pre-sorted prior to execution. In the decoupled task, the user and the robot stacked their own structures, and there was no overlap between blocks. In this configuration, blocks belonging to the user and the robot were scattered all over the table. In the second decoupled task, once again there was no overlap in the user's and the robot's blocks, but this time, objects belonging to the user and the robot were pre-sorted. We found that implicit techniques enable efficient task completion and task parallelization, but they should be augmented with explicit mechanisms to provide users with finer control over how task allocation occurs.